file item 9. Would you like to... Well, file item 9. Discussion of the role of tidal marsh restoration in fish management in the San Francisco estuary. Reiner, are you going to introduce this topic?
Oh, please allow me to introduce myself.
He would be too embarrassed if he let me introduce him, but I will make that attempt anyway.
I don't think we get enough Rolling Stones at these meetings.
So what purpose do you serve at the table if you're not going to do the introduction?
Decorative.
Decorative, yeah.
Okay.
No,
right.
Allow
Gentlemen,
me to
proceed.
at least use a few introductory words to introduce Dr. Herbold. It's a real honor to do that because we go back about at least 30 years. I was in Peter Moyle's class when Bruce was the teaching assistant there, so that dates us. So our career paths have crossed many times over the last 30 years. And Dr. Herbold is now retired at a very young age from US EPA Region 9, where he has been, where he was active for probably 28 years?
21 years.
21 years. So, and Bruce has had a very long career, and part of it was spent as the chair of the coordinating, the interagency ecological program coordinators. And so he knows the delta like the back of his hand, from delta smelt to quagga mussel. Fortunately, the latter hasn't arrived here yet, so hopefully we can prevent that. So with that introduction, I just wanted to let you know that Bruce was instrumental in collecting the synthesis of all of the scientists and panel members that attended the symposium that we held that was co-sponsored by the Delta Science Program and UC Davis and the California-Nevada chapter of the American Fisheries Society back in June. And this synthesis paper is going to show up in print, and if you use the print button on your computer, on the online journal next March that we sponsor and help fund. So this is a preview of that synthesis paper that deals with the extent that we, at this point at least, can predict what the benefits of tidal marsh restoration might be to benefit native fishes. So that was the focus of the seminar, and particularly in light of the biological opinions that are in place, and then also the big Bay Delta Conservation Plan idea of restoring thousands of acres of tidal marsh habitat. We wanted to explore with this panel how much uncertainty there is in the prediction of the benefits. And can we accelerate restoration activities, and how do we use these actions that we put into implementation of tidal marsh restoration to learn and then continuously improve our knowledge for how to proceed with the next big chunk of marsh that we may want to put back into tidal action. So with that, I wanted to pass on the baton to Bruce.
Thank you, Renner. He did well in the class, by the way. So there was this seminar back in June, and it was a great time. We got people from across the country to come and talk about tidal marsh. The title of the seminar was Tidal Marshes and Native Fishes in the Delta, Will Restoration Make a Difference? And sadly, some people went out of that room thinking that the answer was no. And when in fact, and the point of the paper is that the answer is a resounding yes, just not the way that some people would like it to be. And so some people seem to have taken away that if it doesn't work the way that I thought it did, then it can't be any good. And I just want to resoundingly refute that. And so I'd like to talk about a couple of things. First off, it's not that's not a major surprise. Estuaries around the world are nursery areas for fish, for valued fishes, everywhere they happen, practically. Maybe not, well, no, even in Antarctica we're seeing a new thing down there. But That's not surprising, and it happens here. Tidal marsh is a valuable habitat to raise small fish in. It's also a valuable habitat to raise lots of other things in. It also, so it supports not just fish, but a wealth of terrestrial species, and it does that here very clearly. The value of tidal marsh to fish is primarily in situ, that is, in place. You don't sit outside and wait for the marsh to produce something that will drift downstream to you. You go where the food is. You don't wait for the restaurant to send food down the sidewalk. You go into the restaurant. And there are, as Wim Kimmer said, 1 million tiny mouths in there. So they're very productive, and almost everything that is produced there gets eaten there. So access to that by fish is important. I'm going to cover a few other things that define what makes them important. But one of the things to bear in mind is the wonderful document that came out in 2012 about the historical ecology of the Delta. And looking at that, if you compare how much the open channel, that kind of open planktonic area was, compared to wetlands back 150 years ago, it was something like 14, 16 to 1 acres of wetlands to acres of open water. And now it's about 1 to 8. There's about 1 acre of tidal marsh for every 8 acres of open water. So that whole dynamic is different. There may have been, 150 years ago, enough wetlands that some stuff did slosh out into a little bit of open water. But with that 80-fold reversal, where now almost all the water is out in the open water and almost none of it is in wetlands, it's borders on silly to think that that could be a valuable source of food any distance away from that, where that food is produced. So I want to cover 4 things about what makes them valuable. First off, location, location, location. One of the other things that came out of the historical ecology book is that the Delta is not a uniform mass even now. That there are 3 distinct deltas. There's the Sacramento coming down, being mostly a floodplain sort of delta, a San Joaquin River coming in, being kind of a meandering river delta. If you just look at the map as it is now, the San Joaquin River channels, old middle river channels, are tiny little channels, actually, compared to what's coming down the Sacramento side. And it's not just that we built dams. That's the way they've always been. They meander in the south. They flood out onto the floodplains in the north, but there's a main river channel coming down. So that's really different. And they both enter into a third delta, a tidal delta in the middle. And, of course, you have to have major tidal effort if you're going to have tidal marsh. So that was where most of the tidal marsh was. So that tidal historical ecology book has helped integrate a lot of our understanding about how the Delta works now, because some of those processes, most of those processes are still in place. We've just really managed to change them a lot. So we have gone in and we've built levees and dried out a lot of that area that used to be tidal marsh. We've dredged out what used to be shallow channels so that now a lot of that water is not only in channels, but it's in deep, dark channels, so they're not very productive channels. So not only is that taking it away from what had been tidal marsh, but it's putting it into a habitat that really is no good for much of anything productive-wise. Secondly, focusing on functions. Acreage doesn't do much. What we need to be looking at in addition to location is function, function, function. Size does matter. The bigger it is, the more it's likely to do something, and the more likely we will be able to see it do something. If we build a 10-acre site, we probably won't affect very much, and we'd have to look really closely to see an impact on fish populations. But if you build a 1,000-acre site, you're much more likely to be able to go in and see processes at work, see functions going on. Shape matters. One of the cool things that came up at the symposium was Louisiana is losing a lot of its tidal wetlands. And one of the things they found is you can really identify what the functions are by the fact that you're losing some of them. So, for instance, shrimp production is a straight function of how many acres of tidal wetlands you have. As you lose acres of tidal wetlands, you lose acres of shrimp production. But fish like the edges, baby fish like the edges. That's where they hang out, that's where they hide, that's where they eat the food that's falling off of the tidal marsh vegetation. So they can stay there and keep their abundance even as the acreage goes down because it leads to fragmentation. So you get more perimeter even as you lose area. So you lose area, you lose shrimp. But you lose area in a fragmentation way, and that gives more edge for the fish, and the fish do better. So thinking about what the functions are that you're trying to protect is essential in making the tidal marsh work. And thirdly in that, ecosystem matters. There's some cool things that go on. In a usual marsh, wading birds walk along the edge, and they pick off the big fish. Those big fish would be eating the small fish. So there's interactions there on predation that are really quite cool. If you build your tidal marsh so that it supports wading birds being able to pick off the big fish that would eat the small fish, then you get more small fish. This is how it happens elsewhere. It would be good to think about how those interactions happen here. On the other hand, if you're flooding something like we've seen in the Yellow Bypass, and you flood a flat agricultural field, then small fish don't have anywhere to hide, and they get picked off readily, both by predatory fish and predatory birds. So it's really easy to see how some of these functions can be modified. And so you build your tidal marsh, or you place your tidal marsh in areas where it's going to be able to get the benefits that you want. Of course, we also have a bunch of toxic impairments around here, and knowing where those are might control what you do where. So looking at how else we've managed to screw up the system before you start building on it is a good idea. We've also been invaded by a variety of introduced species, clams, vegetation, other things, and they have their own particular needs. And one of the things we found is that velocity and substrate really control clams and weeds. So by looking at what the substrates are, where we're looking for tidal marsh, we can likely make it more attractive to weeds or less attractive to weeds, more attractive to clams or less attractive to clams. So we have tools, but we're not building a food factory. Salinity distribution is the main thing that controls fish distribution if you're down in the salty parts of the estuary. So flow, outflow, and the rest of that will control whether your fish have easy access to the tidal marsh you built if it's in the salty part of the delta and Suisun Bay. And lastly, there are cool things going on in this functional view about productivity. We've been invaded. If there are clams there, there's this very cool interaction of productivity. If it's too deep, then the water's too dark and it's not being very productive, and only the top surface of the water is getting enough sunlight to grow. And so that little productivity gets diluted in all the dark water below it. But if it's too shallow, then too much of the water each day is going through clam siphons, and all the food is getting eaten by clams. So depending on where you are, what the substrates are, what your likely clams are going to be, will control how deep you want your tidal marsh to be. So that you can do this. There are engineering issues on this. The idea that there are uncertainties is a small part of the large fact that we know a whole lot about this estuary that we could be applying. So location, function, changes. And I said I wouldn't disappoint Dr. Goodwin. We are the most invaded estuary in the world. We've seen the impacts of a lot of those invasions. Despite my good friend Reiner's efforts and the importance of doing those efforts to keep quagga out, everyone has tried to keep quagga out. Quagga has always gotten in. Once it's on a continent, it's going to be spread throughout all the suitable waters on that continent. It's a question of when it gets here and what you do about anticipating it getting here. If we had thought about some of the things that had come in, with the time step that we have to anticipate quagga getting here, or zebra mussel, we might have done things differently. We might not have built a diversion out of the South Delta in the first place. So we know some things about quagga. We have seen impacts of other induced species. They muck about with the functions and species that we value. But we can do something about anticipating them. We can start adapting to them. Similarly, I want to finish up with quagga. One of the things we do know about quagga, DWR and the Bureau have done a nice look at what water chemistry will do in determining where zebra mussel, quagga mussel live, and mostly they're going to be south of the Central Delta. There's not enough calcium in the water in the Sacramento River to allow them to grow shells. They like enough calcium, more calcium than is in the Sacramento River. So the problem is mostly going to be about south of the middle of the Delta. we could start doing something about that. We could start putting that into our planning of what we're doing with tidal marsh. There is no simple answer. There might be a simple answer for what you do once the quagga get into your water supply system. There's some really encouraging things going on there. But what it does out in the open water, we can start anticipating that if we choose. We have a bunch of introduced plants. They're spreading rapidly through the delta. They provide great habitat for introduced predators that would not have found that habitat before. And so we have developed a great fishery for those fish as we have been being choked to death by weeds. So there's a silver lining to everything. But our planning needs to incorporate what those plants do and looking at how we can minimize those impacts. And we have some of those tools. One of the cool long things we have is how flow management, salinity distributions, have affected the ecosystem of the bay. Early on in the 20s, a wood-boring worm, actually it's a clam, but it looks like a worm. It has its little clamshell up at one end of a long, skinny body, so it looks like a worm. And they were restricted to water that was saltier than it likes lots of salt in its water. And as we diverted water for agriculture and use upstream and had more evaporation going on up there, the salt regime moved up into Suisun Bay. And if you ride the train down to San Francisco, you'll see some of those piers still sticking out of the water, where the wood got eaten by the teredo worm. And that happened back in the 20s and 30s as the teredo found more suitable salinities up in Suisun Bay. It was as big a change to the ecosystem for humans there as the overbite clam, which came in the 80s. Huge, easily predicted. Yes, if you move the salinity distribution, you will get teredos up there. And if you get teredos up there, they will eat all your wood pilings that you haven't protected from fouling because you didn't think you needed to. But if you thought they were coming, you could have done something. We also have massively changed sediment loads, so our functions have changed. It's there. It's true. I want to finish today talking about how that's being addressed downstream, because I think downstream offers some examples. But just trying to build tidal marsh when there's so much less sediment coming downstream is a problem. If you build a hole, it's not necessarily going to fill up the way you want it to. Where was I? And lastly, as Dr. Goodwin brought out, we are seeing the effects of climate change, but you don't need to just be thinking about climate change. Back in the 1860s, two decades of drought ended with the worst flood we've ever seen. That flood was modeled a couple of years ago by GS at, I think it was 50% of that flood, and it was worse than any earthquake that the GS had predicted its impacts in California. We lose Stockton. We lose a lot of the Central Valley. And the impacts of that don't require any climate change. It just requires a recurrence, as we saw 200 years ago. 160 years ago. And we've been living, as Dr. Goodwin described, in a paradise of wet. Since we started developing water in California in the 20s, we've had a lot of wet years with a sprinkling of droughts. But if you look back at the tree ring data or other data, it's discouraging. But we've seen all of these factor in to what you're trying to protect. And that gets me to what I want to finish with, is that I've been working with the Bayland Ecosystem Habitat Goals update for climate change. It stops at Chips Island. It stops at the western edge of the delta. And it's only looking at what climate change will do downstream. They have a lot, over 100 scientists working on this. They have a lot of industry buy-in. There are a lot of other tools that are being done there. So as they're trying to protect their resources and protect, in the face of also trying to protect infrastructure, they have gone a long ways. And I just haven't seen anything like that east of Chips Island. It's much more broad brush. And west of Chips Island, I think we have a really good example in BEHGU, BEHGU, the Bayland Ecosystem Habitat Goals update, that illustrates how you can take what you know and apply it. And lastly, you cannot win if you do not play. So I was dismayed that the message out of the symposium last June was taken to be that we shouldn't be doing this because it won't do what we thought it might do. And really emphasize that it is really well worth doing. The bigger you do it, the more likely you will see an effect. If you see an effect, you can figure out how to do it better next time. And I would encourage, as part of the Delta plan, to look at this in terms of how can you adapt your results to future conditions without just giving up on the uncertainties. Two things that we do know that are out there are climate change and quagga. We can plan for them. Thank you. Questions?
Dr. Herbold, thank you very much. As you know, this is a policy-making body. We don't all converse in high levels of science discussions. But in the Delta Plan, we've designated 6 priority areas for restoration in the Delta. And according to the staff report that we're going to be receiving after lunch, there are 15 projects that are in consideration or currently underway. As policymakers, what is your advice to us as to what we ought to be concerned about as these projects are moving forward?
2 things. Ask as they come forward how they fit into a landscape view of how does this, 3 things. How does this likely to look in 50 years? And that, in 50 years, quagga will be here, despite Reiner's best efforts. In 50 years, I'm willing to I'll pay any amount of money that I will pay, because I won't be here, so that's safe. But in 50 years, quagga will be here, climate change impacts will be greater than they are now, and we will have seen some recurrences of droughts that we've had before. How will that affect the landscape? How do you do water management? How can we expect water management and human growth in the Delta to alter in those next 50 years in a realistic way? And how does that then, in that landscape, how do your 15 projects fit in? On a smaller scale one, the one I like best, the Lower Yellow Ranch project, went from being a project in which they were going to move millions of cubic meters to make it down into tidal marsh level, because that was what they wanted to build. And the historical ecology book really clearly showed that was really shoveling against the tide, that they were trying to dig a hole in an alluvial fan, and that alluvial fan would still be bringing sediment down. That hole would not be a long-term structure. It would be expensive to build, and it would be fighting against all the processes that were on that location. So how does it fit with the future? And really getting a clear view of what that future is with quagga in it, with climate change in some agreed-upon form. Looking at the past, are these likely to be consistent with the processes that were in place 150 years ago, especially modified by how we've mucked up those processes and the ones that are still there? So things like gradient, et cetera, your fan will still be a fan. You will still have sediment moving down that slope. So will they survive? Look at the history, look at the future, and then look at the functions in those. What are you trying to accomplish? And is that a good, solid basis? I mean, the thing that came out of the June workshop is that building tidal marsh as a way to make food for downstream, either that's not the way it works anywhere else. If you build food, it'll get eaten on site. Any food that gets off site will get eaten by clams. Well, kind of the messages there. Those are discouraging messages for people who wanted to think that you could fill up the deep, dark river channels with pea soup generated by shallow water next door to it. Are those functions actually going to work? So I'd look for functions, I'd look for history, I'd look for future. Do they fit together?
Okay. Gloria.
Thank you, Dr. Herbold, for your comments this morning. When you talked about the landscape and the effect of climate change and drought and so forth, I know one of the tasks that this council has is to look at prioritizing levees. How does that fit into the equation?
Well, we've got something like 1,600 miles of levee, and a lot of them are now protecting areas well below sea level. It doesn't seem possible that we can afford to protect them all. So the first thing to prioritize is which ones you're going to protect. That's way outside my scope of expertise. I don't think we can just walk away. I don't think we can expect that they will continue to stand as they are standing today, because they haven't stood that way for the last 60 years. We keep having levee breaches. Something needs to be done, but I don't think that that's something I can give you good guidance on. But do something, please.
Chris?
Dr. Herbold, should we be designing our restoration projects with a specific outcome, a desired endpoint, or more as experiments to determine what that endpoint might be?
There's some things you can count on as you build tidal marsh. We know some things you'll get. Other things are less clear. The biggest one like that, delta smelt are living in an area that we didn't expect them to be living. 15 years ago, I would have said, no, there's no population of delta smelt that's going to live year-round in fresh water. I would have been wrong. So there are conditions at which you can protect species that you care about, and we learn more about them. But that starts prioritizing where and what you're trying to accomplish. So if you're doing it for delta smelt, doing tidal marsh restoration as a food source for delta smelt, doing it as a refuge place for populations of delta smelt that are not all eggs in one basket, it's probably a good idea. But there's really limited places where you can do that. So that starts refining, okay, this is really important. Of course, if there's a landowner that owns that one really important pocket, you may be having to pay for it or something. But it starts focusing what you're trying to accomplish. If you're trying to protect winter-run salmon moving out, then getting access to your tidal marsh along their migratory route during the year, the conditions when they're likely at problems, in wet years, everything's flooded. You don't need to worry about it. So making tidal marsh accessible to winter-run salmon on their out migration, so they have somewhere to hang out on their way. During dry years, when the bypass isn't flooded, that starts becoming, okay, that's probably important. Flooding the bypass has other benefits. But you start looking at what is the function we're trying to protect, when are the fish most at risk.
It sounds like an opportunistic approach.
Where you've got do the things you can count on, and while you're doing that, improve your knowledge on the things that you're less sure on. Yes.
Okay.
Yes.
Thanks.
One of the things I do want to, I'm going to write a paper one of these days, because I keep hearing people say we don't know enough. And I'm going to go out on a limb here and suggest that what we know about winter-run salmon and delta smelt is way better than 95% of the other endangered species that drive policy. I mean, the mountain of information that we've accumulated on delta smelt in the last 15 years is daunting. I can't keep up with it. It's just, and when I got hired 21 years ago by EPA, I was one of the experts on delta smelt. And now I just, it's overwhelming. And yet people say, oh, we don't know enough. No, I'm sorry. We know a lot. We know enough to do a lot of things. And by doing them right, we can learn a lot more.
One of the minds you're changing is my own on thinking about this, because I keep looking at it thinking that what I need to do is understand enough of the desired endpoint that I can modify the habitat to create the prospect of achieving that endpoint. And what I hear you saying is, well, we know a lot of very specific things that are going to have a likely response, and then when we have a project, that we should take advantage of the circumstances of that project to achieve the desirable end response that we know we're going to get, and then watch and see what happens and take advantage of our learnings to
You can even design things to answer some questions that are important. The Dutch Slough project is designed to see how important is different depth and different sizes. So it's big enough to where you can have small, medium, and large bits of tidal marsh, and you can see, is predation worse in smaller ones than bigger ones? That's an answerable question. You design it. It does all the tidal marsh stuff you want it to do that you know tidal marsh can do, but it also is set up so that you can answer a question. Love it. I wish it was get funded.
Larry?
Doctor, I have a problem down in the South Delta and a lot of the other parts, which invasive weeds, and it seems that the state has had a stop-go attitude at trying to deal with it. And if we build these vast areas of tidal marsh, aren't we just building a nice nursery for these invasive weeds? And if they take all the oxygen out of the water, I don't know many fish that are going to survive in it. Maybe it'll kill the quagga mussels off. I don't know. But it seems that's an area that just has not been dealt with.
Yeah, it's interesting. The Cache Slough complex, where Delta smelt hang out up at the base of the floodplain, at the base of the Yellow Bypass, has remarkably few aquatic weeds in it. And certainly it's not for lack of opportunity for them to get there. So there are places that are not weed choked, and we know some of the things that control that. If there's some salinity, it kills off a lot of them. If there's velocities for floating things, they float downstream and go. Even if they're rooted, if the channels allow some velocities there, they don't like it. If the substrate is not appropriate, too silty, they don't like it. So we can start looking at, well, where is that going to be a problem? Because I agree with you. In the South Delta, I don't have a clue about what to do about most of those channels. And they are meandering little channels. Around the world, they get choked with weeds. And we introduce those weeds. And I don't know. Thermonuclear warfare, I just don't know.
But we have a big chunk of proposed habitat to go down there in that South Delta.
Yeah.
Any other questions or comments? Dr. Herbold, thank you very much. And get to that summary paper on what we know about salmon and smelt as soon as you can, please.
I keep hearing people say this, and I just keep going, there's this mountain of stuff. You know? I mean, we don't have the genome of condors. We've got the genome of Delta smelt. That's just... Anyway, thank you.
Thank you, Reiner. Thank you.
Quagga.